Let's take a step back in time and talk about how we used to move liquids in the old days. Water, oil, and even the fizzy stuff in your soda bottles all traveled through a maze of pipes and pumps. We relied on pumps, pipes, and valves, working together like a city's circulatory system, moving vital fluids everywhere they were needed. To keep track of it all, operators had to physically walk up to every single gauge and meter, carefully jotting down numbers by hand, shift after shift. If something seemed off, they'd have to rush over to a valve and turn it manually, hoping to fix the problem before it got worse. It was a slow process, and mistakes happened all the time. Wrong numbers, missed warning signs, or a burst pipe that went unnoticed until the next morning. The entire system depended on people being in the right place at the right time, constantly on the move. If a pump ran too hard, or a valve was left open by accident, it could waste huge amounts of energy or even damage expensive equipment. Human error was always a constant risk, lurking in every corner of the plant, and if disaster struck in the middle of the night, no one would know until it was too late and the damage was already done. The process was reactive, not proactive, always responding to problems after they happened, never before. Operators simply couldn't be everywhere at once, no matter how hard they tried. It became clear that the world needed a smarter, more reliable way to manage these complex systems. The time had come for a change, a leap forward into a new era of industrial control. Enter SCADA, Supervisory Control and Data Acquisition. This is the technology that quietly powers the modern world of water management, working behind the scenes to keep everything running smoothly. SCADA gives pumping systems a digital brain and nervous system, transforming old mechanical setups into intelligent, responsive networks. Sensors now monitor pressure and flow around the clock, sending data as electrical signals every second, ensuring nothing goes unnoticed. These signals go to PLCs, rugged computers programmed to make quick decisions, like sending alerts if pressure spikes or if a pump needs maintenance. The PLC is the local brain, handling real-time control and making sure the system reacts instantly to any changes. Operators see everything on HMIs, touchscreens showing live diagrams, data trends, and system health at a glance. The main SCADA software runs in a control room, sometimes miles away from the actual pumps, connecting distant sites together. Operators can monitor, control, and respond instantly, all from one place, making decisions that affect entire cities with just a few clicks. No more clipboards, just real-time data and control, accessible from tablets, phones, or computers wherever you are. Alarms pop up if something's wrong, so issues are caught fast, often before they become real problems. The system is always watching, always ready, providing a constant layer of digital security and oversight. Manual rounds are replaced by digital oversight, with every action and event logged automatically for review. The pumping system just got a lot smarter, and the future of water management is here. With SCADA, automation is the next leap. Now, the system can make decisions on its own, following programmed logic. For example, if the water tank drops below 70%, then turn on the pump. If it rises above 90%, turn it off. The system balances loads, running the most efficient pumps as needed. If a pump fails, automation detects it, starts a backup, and alerts the operator instantly. This is fault response, adapting in real time. Automation saves energy, reduces wear, and keeps things running smoothly. Operators oversee, but the system handles routine decisions. Pumps don't just run, they think. Let's take a closer look inside a modern water treatment plant, where technology and innovation have completely changed the way clean water is produced for our communities. Instead of operators constantly walking the plant floor, only a handful now sit in a quiet, climate-controlled control room, calmly monitoring live data feeds on massive screens that display every detail of the plant's operation. Every tank, pump, and valve is tracked in real time. Green means running, red means off, so nothing is left to chance and issues can be spotted instantly. Data is automatically logged, stored, and graphed, allowing operators to review trends, spot patterns, and monitor performance over days, weeks, or even months. If a pump suddenly draws more power than normal, the system immediately flags it, alerting staff to potential problems before they escalate. Operators can quickly check maintenance history, review past repairs, and schedule new ones before breakdowns occur. This is predictive maintenance in action, reducing downtime and saving costs. Automation now handles complex routines like filter backwashing with precision and consistency, ensuring the process is done perfectly every single time. If there's ever a problem, backup pumps kick in automatically, keeping the water flowing without interruption. Operators now focus on managing the system, analyzing performance data, and working together to find ways to improve efficiency and reliability. The job has shifted from manual labor to oversight, decision-making, and problem-solving, making it safer and more rewarding. Thanks to automation, the plant runs safer, smoother, and more efficiently than ever before, delivering clean water with confidence. Technology has truly transformed the role of the operator. The future of water treatment is here, and it's more exciting than ever. Why invest in SCADA and automation? The benefits are huge. First, efficiency. Automation runs pumps only when needed, saving energy and money. Reliability improves as computers don't get tired or make routine mistakes. Operators focus on big-picture issues, not repetitive tasks. Safety is better. Systems can detect leaks or failures and respond instantly, keeping people out of harm's way. Every action is logged, so problems can be traced and prevented in the future. Predictive maintenance means fewer breakdowns and longer equipment life. Fewer staff are needed for routine checks, cutting costs. The system pays for itself through savings and reliability. It's a smarter, safer way to run critical infrastructure. Upgrading to SCADA isn't easy. The initial cost is high. Hardware, software, and retrofitting old systems add up. Proving the long-term savings takes careful planning and engineering studies. Skilled workers are needed, technicians and engineers who can program, network, and analyze data. Cybersecurity is a new challenge, protecting systems from hackers. Despite the hurdles, automation is the backbone of modern infrastructure. For future engineers, understanding these systems is essential. The jobs are about designing and optimizing, not just operating pumps. Smarter systems mean a direct impact on the world: clean water, energy, and manufacturing. Next time you turn on a faucet, remember the science working silently behind the scenes.